Video, I will be explaining how to solve systems of equations with three variables through word problems. So we will be pulling out information from a word problem to create and solve the systems of equations using three variables this time. So our first word problem, a sporting goods store sells footballs, basketballs, and volleyballs. Football costs $35, basketball $25, and a volleyball $15. On a given day, the store sold 5 times as many footballs as volleyballs. They brought in a total of $3,750, and the money made from the basketballs alone was 4 times the money made from volleyballs alone. They want to know how many of each was sold. So what we're going to do first is we're just going to set up the problem. And then at the very end of the video, if you would like to see the solutions, you're welcome to see them. I'm actually going to solve the solutions by using a calculator that I showed in a previous video of how to solve the systems of equations using a calculator. So for this, the first thing, we actually have to be able to actually write the equation. So we do have, I'm going to decide, or that F is going to represent the number of footballs. B is going to represent the number of basketballs that were sold. And obviously V is going to represent the number of volleyballs sold. Now, we don't know how many of each were sold. We don't even know how many total were sold. But we do know the total amount that was sold. I mean, not sold, but we know the total amount that they made. So I know that if a football costs $35, $35 times the number of footballs plus $25 times the number of basketballs, because basketball costs $25, football costs $35, and $15 for every volleyball sold is going to represent the $3,750. Now, the next thing is we know that the store sold 5 times as many footballs as volleyballs. Now, here's the deal. A lot of students are going to want to say, oh, 5 times as many footballs as volleyballs. However, if you actually plug in some numbers here to see if that actually makes sense, 5 times as many footballs as volleyballs, which means footballs, a lot more footballs were sold than volleyballs. So therefore, if I was to plug in like 4 footballs, that means I sold 20 volleyballs, but that doesn't make sense because more footballs were sold than volleyballs. So you can't just say, oh, 5 times as many footballs, so it must be 5F. That actually is inaccurate. It's actually the opposite. Whatever the number of footballs were, it took 5 times the number of volleyballs to equal the number of footballs. And I know that's weird, but if you think about it, whatever the number of volleyballs were, you got to say 5 times that number of volleyball is how many footballs were sold. So that's why it should actually be F equals 5V and not 5F. Now, the next one said the money made from basketball alone was 4 times the money. Now, this is a little different because they use this verb was. Anytime they use the word is and was, a lot of times you can automatically put in equals there. So the money made from basketballs, well, you can't just say basketballs alone because it's talking about the amount of money made. So you have to write 25B because it's the money made from the basketballs was equals 4 times the money made from volleyballs. Well, it took you made $15 for every volleyball, so that's why it's 4 times the amount of money. Now you're going to say, wait, here you swapped where the 5 went and the F and the V, but here you didn't. The way the sentence was actually created is why it actually made a difference. The store sold 5 times as many footballs as volleyballs is not the same syntax as the money made from basketballs alone was 4 times. But instead of dealing with syntax, just think about logically, like, okay, if $30 was made and basketballs was 4 times that amount, then you need to multiply that amount by 4, which is exactly what we did. The amount of volleyballs, you've got to multiply by 4 to get to the amount of money made for basketballs. So we now have our equations. However, they are not lined up because anytime you have systems of equations, all of the variables have got to be lined up correctly. So the V is actually on the opposite side of the equals. So I have got to get the V on the other side of the equals. So I'm going to need to subtract 5v to where it's actually going to be f minus 5v equals 0. Because if I subtract 5v, there's nothing left on the right-hand side. It's got to be 0. And over here, I also will need to subtract the v. So I'll get 25b minus 60v, because 4 times 15 is 60, equals 0. So we have 35f plus 25b plus 15v equals 3750. And then we have f minus 5v equals 0. Why did I put a huge space? Because there was no b. So think about it as a 0b. And then I have a 25b minus 60v also equals 0. Now, why did I leave a space in the front? Is because there was no f inside this equation, which means it was a 0f. So this now becomes your systems of equations in which you can be able to plug into the calculator to find your answer. A furniture company makes loungers, chairs, and footstools out of wood, fabric, and stuffing. The number of units of each of these materials needed for each product is given in the table below. How many of each product can be made if there are 1,110 units of wood, 880 units of fabric, and 660 units of stuffing available? And again, we're just going to set up the problem. Now, in this case, they actually have given us everything. Now, we know the amount of wood is 1,110 units. The amount of fabric is 880 units, and the amount of stuffing is 660 units. Now, we could use L, C, and F, or you could just use X, Y, and Z to represent each different type of product. And so we're just going to write it as we read it. So 40X plus 30Y plus 20Z will equal 1,110. We also know that 40X plus 20Y plus 10Z equals 880. And we know that 20X plus 20Y plus 10Z equals 660. Now that we've set up the problem, we actually have now created our systems of equations to be able to figure out how much of each product, how many loungers can be made, how many chairs can be made, and how many footstools can be made out of the units that are available. A stadium has 49,000 seats. Seats sell for $25 in section A, $20 in section B, $15 in section C. The number of seats in A equals the total number of seats in section B and C. And suppose the stadium takes in 1,052,000 from each sold out event. So I'm going to use A, B, and C to represent the different sections. You could use X, Y, and Z, but since they actually tell us section A, B, and C, I'm going to go ahead and use those. We do know that the total number from section A, the total number from section B, and the total number from section C is going to give us the amount of seats. If you add them together, it should equal 49,000. It also says that the number of seats in A equals, so we automatically can write the actual equal sign, the total number of B and C, which means you just add B plus C together. A equals the total of B and C. And then last, the stadium takes in this amount of money, which is where we get back with how much money was made. Well, we do know that it's $25 for every seat in section A. It's $20 for every seat in section B, and it's $15 for every seat in section C. And that amount of money is going to equal $1,052,000. So we actually now have our system of equations set up. However, in this case, you could use substitution since A is already set equal. You could plug it into both of these equations, and you would have two long equations to solve. Or you can write it to where all the variables are lined up with each other and the equals lined up with each other, and then you can use the calculator. So if you were to use the calculator, this would need to be rewritten as A plus B plus C equals 49,000. And then in order to get A, B, and C on the left-hand side, the equals, you would have to subtract B, so you would get negative B. You'd also have to subtract C to get negative c, and it would be equal to 0 because you're getting both the b and the c on the left-hand side. There's nothing left, so it would be equal to 0. And then the third one would be 25a plus 20b plus 15c equals 1,052,000. And that would be your systems of equations set up. Last, a change machine contains nickels, dimes, and quarters. There are 75 coins in the machine. So I'm going to use N for nickels. I'm going to use D for dimes. And I'm going to use Q for quarters. We know that there's a total of 75 coins. So I know that N plus D plus Q equals 75. We also know the value is $7.25. So I can go ahead and well, what's the value of the nickel? Well, a nickel is 5 cents. I don't like decimals, and so instead of putting 0.05 to keep it as dollars, I'm going to represent it as cents. So 5 cents is a nickel, 10 cents is what a dime is worth, and then 25 cents is what a quarter is worth, and the total value is 725 cents. If you don't have decimals over here, don't put decimals on the right-hand side either. Now here's where this kind of happened at the very beginning with the footballs and the volleyballs. There are 5 times as many nickels as dimes. So there's 5 times as many nickels as dimes. So you have to think for yourself, which one's more? Well, there's more nickels than dimes. There's 5 times as many nickels as dimes. So therefore, you have to think about in this instance. So there's more nickels than there are dimes, which means to figure out how to get from dimes up to nickels, you've got to multiply the amount of dimes by 5 in order to have the same quantity as nickels. There's 5 times as many nickels as dimes. So if you have 10 dimes, that means you had 50 nickels. That's right, because there's 5 times as many nickels. So that did work. If I plug in 10 for dimes, that would give me 50 nickels, so it worked. Now, this systems of equations has been written. However, if we do want to solve it in the future, then all of them needs to line up. So if I want to line this up, well, the N's, the D's, the Q's, and the numbers are lined up for the first 2 equations, however, not for the third. So I need to get the 5D on the left-hand side. So if I do that, I will get N plus D plus Q equals 75. I'll get 5N plus 10D plus 25Q equals 725. And then I'll get N minus 5D plus 0Q equals 0. I like to have a placeholder if there's not a variable, just so that everything stays lined up, because I had to subtract the 5D. And that would be the systems of equation that you actually would put into the calculator to be able to solve for it.